Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about development of surfaces of solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a hexagonal pyramid having base edge 30 millimeter and axis height as 70 millimeter. Now this hexagonal pyramid has got one of its base edges perpendicular to the vertical plane as it is resting onto the horizontal plane on its base. So here we can check the edges AB and ED of this hexagonal pyramid happen to be perpendicular with respect to the vertical plane. Now we have been provided with the information that this hexagonal pyramid has been cut by an auxiliary inclined plane at an angle of 30 degree with respect to the horizontal plane. So here we have got an auxiliary inclined plane or the cutting plane inclined at an angle of 30 degree with respect to the horizontal plane, cutting this hexagonal pyramid in such a way that this AIP passes through the axis of the pyramid 30 millimeter above the base of this hexagonal pyramid. So this is the 30 millimeter distance onto the axis above the base of this hexagonal pyramid. So it is this point of intersection of the auxiliary inclined plane with the axis of this hexagonal pyramid. So with this information, we are required to obtain the sectional top view and the development of the lateral surface of the remaining portion of the truncated pyramid over here. Let us obtain the top view and the front view projections corresponding to this hexagonal pyramid. So as the observer is going to look at this hexagonal pyramid from the top, now we are able to obtain the hexagonal projections corresponding to the base of this hexagonal pyramid onto the horizontal plane in the top view projections over here. So we know that the edge length happens to be 30 millimeter. So with 30 millimeter as the edge length, we have obtained the hexagonal projections of this base of the hexagonal pyramid onto the horizontal plane in such a way that one of the edges of the hexagonal pyramid happens to be perpendicular to the vertical plane. So the 6 points of the base we have evaluated into the top view projection. They are A, B, C, D, E and F over here. So now we need to obtain the axis of this hexagonal pyramid. So we need to join the diagonals AD, BE and CF over here. So wherever these three diagonals they are going to intersect with each other, we obtain the points O and O1 onto the top view projections over here. So O, it is the axis point corresponding to the apex, whereas O1 is the axis point corresponding to the base of this hexagonal pyramid. So having obtained the top view projections corresponding to this hexagonal pyramid, let us evaluate the front view projections of this hexagonal pyramid into the elevation projection view. So points B and A of the base will be projected as B dash and A dash onto the XY reference line. Point C and F of the base, they will be coinciding with each other and they will be projected as C dash, F dash onto the XY reference line. Similarly, the axis point of the base O1 has been projected as O1 dash onto the XY reference line over here. So O1 dash, C dash and F dash, they have all coincided with each other. And the edge points D and D of the base, they have been projected onto the XY reference line as D dash and E dash points over here. Now we know that the height of the axis happens to be 70 millimeter. So once we mark axis height corresponding to the hexagonal pyramid as 70 millimeter, so the apex point O dash we will be able to locate over here. And once we locate the apex point O dash onto the axis at a height of 70 millimeter from the XY reference line, now we can join all these slant edges corresponding to the hexagonal pyramid. So here we will find that the slant generators O dash B dash and O dash A dash, they have overlapped. The slant generators O dash C dash and O dash F dash, they have overlapped. And the slant generators O dash D dash and O dash E dash, they have also overlapped into the front view projections over here. And again, one thing we need to observe, that the slant generator OA, it lies on the rear side. So into the front view projections, it will not be visible to the observer, as the observer is going to look at this hexagonal pyramid from this side. So we should have obtained the hidden line projections corresponding to the slant generator O dash A dash. But this slant generator OA has been overlapped by the slant generator OB, which is lying onto the front side of this hexagonal pyramid, which is visible to the observer. So in the front view, we are going to obtain object line projections corresponding to the slant edge O dash B dash, overlapping or superseding the dotted line or the hidden line projections corresponding to the slant edge O dash A dash over here. Similarly, the slant edge OF also lies on the rear side and it will not be visible to the observer. But this slant edge OF has also been overlapped by the slant edge OC, which is lying onto the front side and it is visible to the observer. Therefore, the dotted line projections corresponding to the slant edge O dash F dash into the front view projections, they have been superseded or they have been overlapped by the object line projections corresponding to the slant edge O dash C dash over here. So again, we are not able to observe any hidden line projections corresponding to the slant edge O dash F dash over here into the front view projection. And finally, again OE slant generator, it is again lying on the rear side. So it is not visible to the observer in the front view projections, but this slant edge OE, it has been overlapped by the slant edge OD, which is lying onto the front side and it is visible to the observer. So the front view projections corresponding to O dash E dash should be drawn as hidden line projections over here. But these projections, they have been overlapped by or superseded by the object line projections corresponding to the slant edge OD into the front view projections over here. So O dash D dash object line projections in the front view, they have overlapped with the hidden line projections corresponding to the slant generator O dash E dash over here. So we have been able to obtain the front view projections, we have been able to obtain the top view projections corresponding to this hexagonal pyramid. So now we know that an auxiliary inclined plane inclined at an angle of 30 degree with respect to the horizontal plane, it intersects with the hexagonal pyramid and this AIP passes through the axis of the hexagonal pyramid at a point 30 millimeter above the base of this hexagonal pyramid. So onto the axis 30 millimeter above the base. So this intersection point of the auxiliary inclined plane with this hexagonal pyramid has been obtained over here. So now this AIP inclined at an angle of 30 degree, it intersects with the hexagonal pyramid passing through the point on the axis at a distance of 30 millimeter from the base of the hexagonal pyramid has been obtained. Now we observe that this portion of the hexagonal pyramid has been removed. So we have discarded this portion of the hexagonal pyramid as it has been intersected or cut by this auxiliary inclined plane. So this is the remaining portion of the solid or the hexagonal pyramid which has been left behind. Now let us obtain the different points of intersection which are obtained by virtue of intersection of this hexagonal pyramid by this auxiliary inclined plane. So here we have got 2 points of intersections, 1 dash and 2 dash obtained onto these slant edges O dash A dash and O dash B dash respectively. Point 1 dash happens to lie onto the slant edge O dash A dash, while point 2 dash happens to lie onto the slant edge O dash B dash over here. So let us obtain the top view projections corresponding to these 2 points of intersections. So if we draw a vertical projector line from 1 dash and 2 dash, wherever this vertical projector line from 1 dash and 2 dash, it is going to intersect with slant edges OA and OB in the top view projections. So we are going to obtain points of intersection in the top view as point 1 and point 2 respectively. So here we have observed point of intersection 1 happens to lie onto the slant edge OA. Point of intersection 2 happens to lie onto the slant edge OB over here. Now the next 2 points of intersection of the cutting plane with the hexagonal pyramid happens to be 3 dash and 6 dash. Point 3 dash happens to lie onto the slant generator O dash C dash, while point 6 dash point of intersection happens to lie onto the slant edge O dash F dash over here. So now if we draw a vertical projector line from the points 3 dash and 6 dash of the front view elevation into the top view projection over here, now we can see that we are not able to obtain any point of intersection with OC or OF over here. Why? Because these 2 points 3 and 6, they are lying in the perpendicular direction of the observer. So since we are looking from front, so this point will not be visible to the observer from the front direction. So what we have to do in order to obtain the intersection points 3 and 6 into the top view projections over here, we have to look at the solid from the right hand side. So when the observer is going to look at the solid in the 90-degree orientation or from the right hand side, points 3 dash and 6 dash, they will be projected onto this slant edges O dash A dash and O dash B dash as points 3A dash and 6A dash over here. That is, we are trying to establish relationship between the height of this point of intersection and the radius which we are able to observe over here. So since this radius, that is 3 dash 3A dash 6 dash 6A dash, it happens to be parallel to the horizontal plane. So if we draw a vertical projector through these 2 points 3A dash and 6A dash into the top view projections, now we will be able to observe location of the 2 points 6A onto the slant generator OA, and the second point is 3A onto the slant generator OB over here. That is, this radius, since it is parallel to the horizontal plane, so in the top view projections, this radius, that is O6A and O3A, this will happen to be true length of the radius over here. So now we have obtained the true length of the radius into the top view projections corresponding to the height of this point of intersection. Now once we obtain the true length of this radius O6A onto slant generator OA and true length of the radius O3A onto the slant generator OB. Now with O as the center, radius O6A, we will be drawing an arc so that this arc or this true length of the radius should be transferred into the slant edge projector, which is OF over here. So this way point 6 will be obtained over here. Similarly, we have obtained the radius O3A onto OB. So since this is the true length of the radius with O as center, 3A as the radius, again another arc we are going to draw so that this true length of the radius we are able to transfer onto the slant generator OC over here. So point 3 will be obtained over here, point 6 will be obtained over here onto OF. So now here we need to understand there is a definite relationship between this height of point of intersection and the radius which will be obtained over here. Had this point been lying over here, radius would have been smaller. So this radius, if we transfer it over here, points of intersection would have been obtained closer to the point O over here at a lesser radius. Had this point of intersection located somewhere here, more radius we would have obtained over here. If we transfer this larger radius onto the top view projections, so these 2 points would have obtained at a larger distance from the point O over here. So this way by looking at the solid from the right hand side or 90-degree orientation, we have been able to transfer this radius corresponding to this height of points of intersection from the base over here into the top view projections, that is points 3 and 6. They have been appropriately located onto the slant edges OC and O6 respectively. Now the next 2 points of intersection, they happen to be 4 dash and 5 dash. So these 2 points of intersection, they are available onto the slant generators O dash D dash and O dash E dash respectively. Once we draw the vertical projector from the points 4 dash and 5 dash onto the top view projections, now the intersection of this vertical projector with slant edge OD top view projections over here, it will provide us with the location of the point 4 in the top view projections and the intersection of this vertical generator through the point 5 dash with the top view projections of the slant edge OE over here. So this intersection point will be obtained as point 5. So all the 6 points of intersection, they have been appropriately located into the elevation projection view. All the 6 points of intersection, they have been appropriately located into the plan projection view. So if we join all of these points of intersection in the top view projection, now the sectional top view we have been able to obtain in the top view projection. And now regarding the non-truncated slant edges, so 1A, 2B, 3C, 4D, 5E and 6F. So these are the slant edges which have not been cut by this section plane over here. So with this, we have been able to complete the construction of the sectional front view projections and the sectional top view projections of this hexagonal pyramid, which have been intersected by a cutting plane inclined at an angle of 30 degree with respect to the horizontal plane. Now we are required to obtain the development of the lateral surface of the remaining portion of the truncated pyramid over here. So now we observe these slant edges OA, OB, OC, OD, OE and OF in the top view projections. They are all inclined with respect to the vertical plane. So the apparent lengths of all of these slant edges in the top view projections, they are available with us. Similarly, the slant edges represented in the front view projections O dash A dash, O dash B dash, O dash C dash, O dash D dash, O dash E dash and O dash F dash, they also happen to be inclined with respect to the horizontal plane. So we are not able to obtain the true length of the slant edge of this hexagonal pyramid straight away. So what we have to do, we know that all the slant edges, they are going to measure the same. So what we are going to do over here, we are going to draw a horizontal projector line from the point O over here. We'll pick up any one apparent length of the slant edge over here. So OD slant edge apparent length we have picked up. So this slant edge apparent length, it is inclined with respect to VP. So we are going to rotate this apparent length with respect to the point O, so that in the rotated view, this apparent length should become parallel to the vertical plane. So OD1, it is the new orientation of this apparent length of the slant edge OD, which happens to be parallel to the vertical plane. So from point D1, if we draw a vertical projector upwards, wherever this vertical projector drawn through the point D1, it intersects with the horizontal projector drawn through the point D dash. So this point of intersection provides us with the location of the true length corresponding to the edge O dash D1 dash over here. So point D1 dash has been obtained once we join O dash D1 dash over here. So this is the true length of the slant edge of the hexagonal pyramid. Now we have observed that all the 6 points of intersection 2 dash 1 dash 3 dash 6 dash 4 dash 5 dash, they have been obtained onto the apparent lengths corresponding to the slant edges which are visible to us in the front view projection. So now we want to obtain these radii corresponding to these 6 points of intersection onto the true length over here. So from 2 dash and 1 dash, if we draw a horizontal projector line, so we will be able to obtain the true length of the radii corresponding to the points of intersections 2 dash and 1 dash. So this true length radii will become 2 1 dash and 1 1 dash. Similarly, corresponding to the points 3 dash and 6 dash, again if we draw a horizontal projector line onto the true length of the slant edge generator, now this radius, it will be O dash 3 1 dash and O dash 6 1 dash. So this radius we will be marking when we have to locate the points 3 dash and 6 dash onto the development projection view over here. And finally, corresponding to the points 4 dash and 5 dash which are located over here, again we have drawn a horizontal projector line onto the true length. So this distance will be evaluated as true length of the point of intersection from the point O over here. So this radius will be O dash 4 1 dash and O dash 5 1 dash over here. So let us proceed with the construction of the development of the lateral surface of the hexagonal pyramid. So we know this true length radius O dash D1 dash. So this is the true length of the slant edge. So with this radius, all the slant edges, they are going to measure the same. So we start from point A over here. So we have got the radius is equal to OA1, and now 6 arcs we are going to mark corresponding to the edge length of the base equal to 30 millimeter. So A1 B1 distance radius will be 30 millimeter. Similarly, at another 30 millimeter radius, C1 will be obtained, D1 will be obtained, E1 will be obtained, F1 and A1 points, they will be obtained over here. Now we can join different slant edges over here. So these are the true lengths of different slant edges which we have marked over here. And once we join all the base points, so the 6 edges of the base of the hexagonal pyramid, they have been appropriately marked into this lateral surface development over here. So now let us locate these 6 points of intersection onto the development surface area. So now onto OA1, the point of intersection which is lying, this happens to be 1 dash. So this radius O dash 1 dash is the apparent length radius. So the true length radius we have obtained as O dash 1 1 dash. So once we measure this radius O dash 1 1 dash, plot this radius on this side and on this side. So point 1 1 has been appropriately located over here. Next point happens to be point 2 dash. So again at the same radius, same as 1 dash. So the true length O dash 1 1 dash is equal to O dash 2 1 dash over here. So at the same radius onto the slant edge OB1, we mark the same distance over here, point 2 1, which is the point of intersection of the cutting plane with the slant generator OB will be located over here. Next point of intersection is 3 dash. So this is the apparent length radius. So point 3 dash happens to lie on slant edge O dash C dash, which is the apparent length of the slant edge. So now the true length will be this one. So the true length of the point 3 dash will be O dash 3 1 dash. So this is O dash 3 1 dash. So onto OC slant edge, this is OC1 slant edge over here. So onto the slant edge OC1, we mark the distance O dash 3 1 dash over here. So point 3 1 has been evaluated over here. We also know that onto the edge O dash F dash, point 6 dash will be lying, and the distances of the points 3 dash and 6 dash from O dash, they are the same. So now we'll measure the distance of O dash 6 1 dash, and onto the slant edge OF1, if we mark the same distance, point 6 1 will be located over here. Similarly, next 2 points of intersection, they happen to be 4 dash and 5 dash. So 4 dash is available onto slant generator O dash D dash. 5 dash is available onto slant generator O dash E dash over here. So now the true length of these 2 points, they happen to be the same. O dash 4 1 dash, O dash 5 1 dash. So we'll measure this distance O dash 41 dash and O dash 51 dash. So now on to OD1, if we mark this distance, 0.41 will be located. On to OE1, if we mark this distance, 0.51 will be located. So all the points of intersection, so their true lengths, they have been appropriately marked into the lateral surface development view. And now we can join these slant edges which are still intact, which have not been cut by this cutting plane. So we can join all of these slant edges in the lateral surface development view over here. So this way we have been able to obtain the sectional front view projections, sectional top view projections, and the lateral surface development corresponding to this truncated hexagonal pyramid, which has been intersected by an auxiliary inclined plane inclined at an angle of 30 degrees with respect to the horizontal plane, and this cutting plane passes through the axis at a height of 30 millimeter from the base of the hexagon, and one of the edges of this hexagonal pyramid, it happens to be perpendicular to the vertical plane. So this is all for today. We are going to continue with further discussion regarding few more illustrative cases of development of surfaces of the solids in the coming lectures. So thank you very much. Thanks a lot.